Good evening, everyone. On behalf of KS School of Engineering and Management, it is my pleasure to welcome you all to this most awaiting ATAL AICTE sponsored 6-stage online FTP on Nanomaterial and Energy Storage Sustainable Future, organized by the Department of Physics, KS School of Engineering and Management, Bengaluru, in association with KS Research and Innovation Foundation. I am Professor Pavitra J, Coordinator, Department of Physics, your host for the day. Kamawari Sangam Group of Institutions is dedicated to supporting faculty development by promoting professional growth, encouraging research, organizing academic competitions, and providing state-of-the-art infrastructure. The institution fosters a collaborative learning environment and recognizes exceptional achievements, ensuring that faculty members stay competitive and proficient both within and beyond the college. Under this roof, we are proud to have 5 esteemed institutions: KS School of Engineering and Management, KS Institute of Technology, KS School of Architecture, KS Polytechnic, and KS PUC. Together as one family, we share our resources, expertise, and experiences, cultivating an environment that promotes growth, learning, and success. KSSEM has been standing tall over a decade, consistently emerging as a pioneering institution in the fields of research and innovation. It is our privilege to welcome today's chief guest, Dr. H. Nagana Gowda, Sir, Former Director, National Training Center for Solar Technology, Karnataka, Power Corporation Limited. Dr. H. Nagana Gowda, Sir, is an accomplished professional with extensive experience in the fields of power electronics, renewable energy, and solar technology. Welcome you, sir.
Thank you, madam. Good evening. Thank you.
I would like to take a moment to welcome our beloved Principal and Director, Dr. K. Ramanarasimha, sir, for his unwavering guidance and leadership have always been a beacon of inspirations. We welcome you, sir.
Good afternoon, all of you. Respected honorable members of Kamawara Sangha, Chairman and members of KS Group of Institutions, all principals, respected Professor and Head of the Department, all the professors, staff members, and also Dr. Swami sir, with esteemed participants from the various esteemed institutions. First, I would like to congratulate the management, principal, organizing committee, and also department professor, along with the staff members. It is the responsibility of the government to provide basic needs to the society. The basic needs are providing education, medical, transportation, energy, etc., etc. Among the basic needs, energy is the one which is the basic need for the overall development of the society. Today, the energy required for domestic, industrial, and other sector is increasing. At the same time, we could not able to generate and supply as per the demand requirement, because to generate electricity from the conventional, we have limitations, constraints, commercial effects are there. As of today, the total installed capacity in our country is more than 4,60,000 megawatts. Out of which today we are generating more than 52% from the petrol, diesel, coal, etc., about 11% from the hydro, about 1.77% from the nuclear, about more than 35% from the non-conventional renewable energy sources. Whatever the resources are there, petrol, diesel, coal, etc., we have consumed more than 60%. Whatever the balances are there, will not sustain our maximum another 100 years. In this context, renewable energy sources and also R&D in the nanotechnology and energy storage system is very much required.
And now modestly request our beloved principal, sir, to share a few words with us. Over to you, sir.
Good evening, everybody. Dr. H. Naganagowda, sir, who is the chief guest of this inaugural function. Dr. D.R. Swami, who is the executive director of KS Research and Innovation Foundation. All my HODs and the dear participants who are participating in this AICTE ATAL sponsored 6-day online faculty development program. Madam has already given a small introduction about our institution, KS Group of Institution. In fact, Kamawari, it is run under Kamawari Sangam. Kamawari Sangam is basically a non-profit oriented charitable organization. Under Kamawari Sangam, we have totally 5 educational institutions, which Madam has already mentioned. So what I would like to add is that KS Group of Institution, whether it is an engineering college or architecture college or PU college, it is known for quality education. We never compromise in the quality of education, and recently in 2023, we have added a wing known as KS Research and Innovation Foundation. headed by our Executive Director, Dr. D.R. Swamy. The purpose of starting this KS Research and Innovation Foundation is to create awareness among the faculty members how to write the proposals for FTP, how to write the proposals for research funding, and also to establish some of the proper research centers and innovation centers as Dr. H. Nagangowda was mentioning. So in this regard, first of all, I would like to thank our management for starting KS Research and Innovation Foundation and also for encouraging us for this faculty development program. My special thanks goes to Dr. Swamy sir, because he is the main instrumental person who is responsible for getting this ATAL sponsored 6-day online faculty development program. Starting from the writing of the proposal, FDP proposal, everything is taken care by Dr. Swamy, and once we got the funding, once we got the approval, it is further taken by the Department of Physics.
And may I now request Dr. Swamy sir, the Executive Director of KSRIF, to say a few words with us.
Okay.
Over
I'm
to you,
not the
sir.
expert, but okay. Thank you, madam. Good evening to one and all present in this online inaugural session. So, just now we are able to see the inaugural address by Dr. H. Nagangowda. He is a very good well-wisher of mine, and also again my principal, Dr. Ram Narasimhan, also introduced our institutions and whatever the initiatives we are doing to promote research in our campus.
That series of students activities like AWIM and DAJA SEAEI India. He is recipient Guru Award from SCE India Foundation for his contributions to the students of India. He has 120 technical papers, 4 books and 4 patents to his credit. We would like to welcome Dr. K.C. Ora sir on this beautiful introduction. We are very overwhelmed and joyous to read your profile, sir. Thank you for being with us, and over to you, sir.
Thank you, Kirti sir. Today I am going to speak on transition from CNG to hydrogen in storage for sustainable mobility. You all know that we need to control the carbon footprint. That means we need to reduce the carbon dioxide emissions. And if we don't reduce the overall carbon dioxide emission, due to global warming, the ambient temperatures will go on increasing, and the days are not far away. Whatever you would see here written in the green is their advantages, and whatever in the red are their disadvantages. Among the advantage of lithium-ion battery, the whole world is after that because of its relatively high specific energy or energy density and large voltage window. And moreover, we can keep this device stored for quite relatively longer time. On the other hand, electrochemical capacitors, they have much lower specific energy but significantly higher specific power, and they offer significantly high operational lifetime. And more importantly, in line with today's topic, the materials and carbon footprints offered by electrochemical capacitors is remarkably lower than that of the materials used in lithium-ion batteries. We will see how is it as we go by.
I'm going to discuss about the multi-phase flow. 1 minute, let me switch off the video. Fine. So today I will discuss about multi-phase flow. I will go for very basic fundamental part of multi-phase flow, and I will describe little bit about the numerical modeling to solve a particular flow for 2 phase. So first of all, if I am going to discuss about the multi-phase flow, solidly we know there are 3 states of matter: solid, liquid and gas. And whenever in a flow there are more than two or more than two phases are there, it is known as obviously multi-phase flow. So now the question is why this multi-phase flow is very important nowadays. Obviously, it has several applications. First of all, if I am going for the basic application of multi-phase flow,
the government is having the set a goal of what you call the net zero by 2070. The means what you call the 10, we like to go for completely it's a carbon free an emission-free country by 2070. There is a mission, there is a target. So in which government has started as in one policy is a green hydrogen missions, where it's a 2030 have the target what you call the 5 million metric ton of green hydrogen generations at India is concerned. We have the enough potential of what you call the solar energy, almost 748 gigawatts of potential of solar energy we have in India is concerned. We convert into that solar energy into the hydrogen, probably using some electrolysis method. It is that will be one of the best one. Where this mission outcome, where it's mentioning that almost 6 lakh new green hydrogen jobs which is going to be established, going to be created. So these missions where almost 125 gigawatts of renewable energy for the green hydrogen generation is going to be established. Once we are right now around almost 60 gigawatts as per 2024 data is concerned. Where also we are 50 million metric tons of carbon abatement cumulatively. We are going to reduce it. That is going to be in a target. So it is well connected, this topic on this sustainable futures. Over 8 lakh crore investment also so directly and indirectly is happening. Major companies which is already they started business on this what we call the green hydrogen business, where India is having what we call that oil import. It's happening almost. It's going to rise almost 6.5% in September when this data is taken in the last December. Where we are in a TPS and commitment, where on the climate goals, it is where the renewable energy capacity last 10 years, probably we can check the Central Electricity Authority. Energy capacity is installed multiple times. So as India is having what we call a good capacity to invest this sunshine sector, we have the enough potential of the solar, and also moreover the need for rechargeable batteries. Just one second. Oh, okay. Sorry, some disturbance there, so I thought I'll come this side. So there are different types of batteries in terms of materials. Lead acid. हेलो लेक्चर में पशु फोन कॉल कर जा रहा हूँ एयरपोर्ट पे हूँ लेक्चर दे रहा हूँ. So there are lead acid battery which has been predominantly used in cars to ensure that we start the engine, we switch on the lights, horns, power window, and all those things. And then we have the traction battery, that is nickel cadmium battery, nickel metal hydride, lithium ion, lithium polymer, sodium sulfur, and zinc. So let's quickly look at the lead acid battery. Lead acid battery have not changed much from the very early design. That means it has an anode, cathode, and a liquid electrolyte, and each cell is of 2 volts. So if you combine into 6, then it becomes a 12-volt lead acid battery. And it uses water and sulfuric acid, that means the diluted sulfuric acid as the electrolyte, right? And so lead oxide, sulfuric acid will give you the charge, and that's how the ions will move in one direction and the electrons will move in the other direction, and that's how it will charge. So a nominal battery parameter for a lead acid is specific energy is around 20 to 35 watt hour per kg, energy density is around 54 to 95 watt per liter, and the specific power is around 250 watt per kg. The nominal cell wattage is 2 to 2.1, and it has an efficiency of around 80%, and so on. Yeah, so here you can see the lead acid battery construction. And then we use electrolyte to top up and charge regularly. So there are various types of lead acid battery also based on its definition of packing, electrolyte, and the use. Then we go to the nickel-based battery, the pencil cell what we
see the range of commercial battery using nickel in the positive electrode has been developed since additions was in the late 19th century. So whether it is nickel iron, nickel zinc, nickel cadmium, and nickel metal hydride batteries, this has been very popular and it has shown a very good promise. We also have a nickel zinc battery which has a reasonable performance. It has very limited life of 300 D cycle and it's not discussed further, right? So nickel zinc battery is out. Okay. So nickel cadmium battery was considered to be one of the main competitors to the lead acid battery. So of all these nickel battery, nickel cadmium battery became very popular and have nearly twice the specificity of lead acid battery.
Speed gradually will be increasing, and so the individual EMF also will be increasing in its frequency, and terminal voltage also is increasing at the speed of say 12.5 meters per second to 25 meters per second, which is the rated speed of the wind electric generator. The RPM of the machine will be 36 RPM revolutions per minute. Now, with the same details, the frequency of the generated voltage will be 18 hertz, and the output voltage is 690 volts. So, 18 hertz AC voltage, 600 volts terminal voltage of this wind electric generator is the rated output at 2.1 megawatt. It is able to give 2.1 megawatt with 18 hertz and then 690 volts output. So this is again fed into line side converter to make it DC. Then the DC is inverted to make it suitable for the grid voltage. So this is an overview of one of the latest machines. Now, coming to system load without and with regulation. Base load, the demand of the system, the electrical demand of the power system will be varying from a minimum during off-peak conditions, during night load conditions, to during daytime it will gradually increase, and it will be reaching its peak during evening, and then after the evening it will gradually come down to again a low level. The ratio between off-peak demand to peak demand, as we discussed, is of the order of around 0.6. So, in this is the base load where the generators will be running continuously. The generators that run continuously will be like nuclear units, thermal units, and the run-of-the-river units, etc. Run-of-the-river hydro units, etc. And this is the zone in which renewable energy generation is tapped. Renewable generation comprises of during night times wind electric generation is there. During daytime solar energy generation is there. Of course, here representation solar energy is somewhat less, but might have been changed now. And again in the evening times the wind dominates. The one advantage with the renewable generation is during other than night conditions, during night conditions the wind electric generation will be dominating. During daytime the solar energy will be dominating. So if we have a hybrid power plant of wind and solar, then probably we will have stable power generation without much variation. Otherwise we will have a lot of variation in the renewable energy generation.
So all these things happens in the powertrain. So this is about a conventional engine propelled vehicle, right? So this is what people know, and this is the this is called the powertrain version of the powertrain portion of the vehicle, and this is what people understand by default, right? But then we are now moving on to electrified vehicles. So it can be pure electric vehicle or hybrid electric vehicle in which there is an engine as well as motor. So the modern hybrid electric vehicle may look something like this. So here we have the, let's say, starting with the fuel filler, and then there is a fuel tank which will the fuel tank will again that will provide fuel to the engine, and the engine will have combustion and it will generate the power. But in a hybrid electric vehicle, we have a motor also that also produces power, and then both of them they can get coupled, and then they can, again, depending on the configuration of the engine and the motor, they will kind of deliver simultaneously. They may simultaneously or one by one or whatever based on the configuration and based on the strategy. They will be instrumental in delivering power to the wheels. But then that's not the end of the story, right? Because the engine and motor, right, they are again electromechanical systems, and then to take care of them, we have electronics. So we have, let's say for engine, there is something called engine controller. For motor, it is heavy. So here, either it is electrical power or whether it is mechanical power. For mechanical power, we have to convert from chemical energy to mechanical energy, right? So then there's a lot of thermal effects here. So engine gets heated up. It cannot continue to get heated. It has to be cooled to within some temperature range. So for that you need a thermal system, the cooling system there. So which will, and not just for the engine, but also for the motor and the inverters and so on. So this is about a very broad way of looking at the hybrid electric vehicle. So let us now, let us look at it a bit more deeper. So this is one configuration of the hybrid electric vehicle called the parallel. There are three kinds of categories of hybrid electric vehicles. One is the parallel, the other is series, and the third one is the combined series and parallel. So the one that we see is that of the configuration of a hybrid electric vehicle. So here we have the wheels, and these wheels are driven by two power sources. So one is the engine, the other is the motor. So you can see there is a motor, and this is the motor, and this is this motor, the torque of the motor and the torque of the engine gets coupled here, and then it produces the net torque that is desired at the wheels. So that is, yeah. So this is looks quite simple. Both of them are contributing and so on.
Has increased. This is for the entire world. What we use the most? Oil, coal, and recently a lot more gas, which is natural gas. And then there's a little bit of nuclear, which is increasing a little bit. There's a little bit more of hydropower. And there's wind, which has in some places where they can actually use wind. Solar is catching up a bit. And then there's, biofuels, and then there's everything else. This is how energy is consumed as of 2020, 23, 2024. Now, there's another graph. This is primary energy consumption. So primary energy, just to remind everyone, is energy that is naturally available. Secondary energy is energy that is converted from one thing to another thing. So if you look at primary energy sources, traditionally they've used biomass, right? You use wood for cooking, heating, various other things, and then so you use biomass in general, or we have used biomass in general as a species. So there's that. That's kind of remains more or less constant over the last 200 years. Then there is coal, which suddenly picked up, around 1850 or so, when people started building railways, especially in large amounts, and they started building railways all over the place. And then we also had various other ways, sort of improved steam engines and sort of things like that came up. So that has gone up. Of course, once we figured out how to, build thermal power plants.
Pressure, you can see here, differently. In the common drive, we have different. It is a 1000 bar. If you take normal engine, it has a 300 bar, they use high pressure. But if you use 1000 bar, for a well feeding engine valve, solenoid, we have solenoid valves, as opposed to low pressure field pump. The injector is a pump nozzle, it is injector here. You can see here nozzle, the injector here. So current generation common rail diesel engines now feature the piezoelectric injectors for increasing precision with a fuel pressure up to 2500 bar also is coming nowadays. Of course, these are all some experimental situations, but 1000 bar we can use compared to normal engines, 300 bar. So with high pressure, what happens? The high pressure compressor, we can have a better high power combustion can be happened. We can have more power and less emission. Go to the next slide. Then you can see here. Of course, there are so many common rail engines requires a very short no heating time, depending on ambient temperature and so on. Okay. Of course, when you are using the CLD engine, you are using high pressure. So when you are using high pressure, naturally there will be wear and tear, or the parts will be breakdown will happen. Or since it is high pressure, then temperature naturally will be high in a combustion, so we require a lot of cooling. Or there is a lot of leakages can happen between these pumps. So there is a high chances of this. Next slide. So that's why we can use this to control this proper appropriate fuel, injection timing, so on by using the electronic.
Today, even though utilization of petrol, conventional or non-conventional, every moment energy requirement increases. At the same time, we could not able to generate and supply as per the demand requirement, because to generate electricity from the conventional, we have some limitation, constraints, or commercial effects are there. As on today, we are generating more than 36% from the renewable energy sources. If we generate more than 40, 50, 60% from the renewable energy, definitely we can achieve energy independence in the energy sector. So no doubt in Bangalore and bigger cities you will get the quality supply. If you go to the rural area, are you getting quality supply? No. Why? It may be a some voltage problem will be there, energy cut will be one way or other way, we are facing lot of problems. Our aim is to what? Our aim is to satisfy the customer needs with emphasis on quality supply, with emphasis on safety, quality, power is very much required. But that is not happening today. If come to the conventional, for example, in Karnataka, already we have installed more than 3,500 megawatt coal-based power project at Raichur and Bellary. In Karnataka, we don't have any coal resources. Whatever the coal we required, we have to get it from our neighboring states, Andhra, Orissa, Bihar, or sometimes from the other countries. Because of your source, where you can connect your load. Load means I am talking electrical load. Source means I am talking electrical source. So, for example, here in this example, the generating station, you can see my cursor here. The generating station can be anything. Can be anything means we have different generating stations like coal-based power plants, that is called thermal power plants. We have hydro power plants. We have nuclear power plants. We have solar power plants. We have wind power plants. So we have any power plant. Finally, that power plant will generate some power. That power has to transport to the directly to the load. So the load means consumer. So how we are transporting by using certain mechanism called transmission and certain mechanism called distribution.
Dr. Deepa Patil, ma'am, you had raised your hand. If you want to speak with me. Yeah.
Actually, the sessions were very good, sir, and very informative.
Lata Kumari from BMS College of Engineering,
Yeah.
from Present Department. I've been to this FTP for all the days, and I found most of the like talks were very interesting and quite informative. And I hope I got a lot of information from this FTP. I'm very thankful to our organizers and the partners and the speakers for this great opportunity. Thank you very much.
It's a nice program, sir. Specifically, the session by Ms. Tilottama Srinivasa regarding biomass for sustainable development. It was very informative, and I had some questions in that, and it was informative quite well. Then Dr. Somanath Sengupta also in regarding modeling, simulation, energy management EVs. This was also very helpful to me, and it was overall a very good experience. I'm so thankful to all the organizers. Thank you, sir.
In this FTP, since I'm also from cases here, I've seen their efforts through this process. This FTP was very helpful, very enhancing, very insightful. All the sessions conducted by our physics department was very helpful for us. Thank you, Kirti sir, Pavitra ma'am. Thanks for this opportunity to for the insightful sessions and to enhance our knowledge more. Thank you, one and all.
Thank you, Ashwini ma'am. Thanks for joining with us for all of the 6 days. Thanks for gaining the knowledge too. Wish we will be taking forward like this in the same sense for upcoming days, both offline and online. Thank you so much, ma'am, for your kind words.
Thank you, sir.
Very good evening, one and all. We have come to the end of the session. We will be taking part in this valedictory program with all of you. On this note, I would like to welcome Mrs. Pavitra ma'am, Head of the Department of Physics, KSSEM. Ma'am, are you audible?
Yes, sir.
Okay,
Am I audible, sir?
Yes. Okay, ma'am, you are audible, and over to you, ma'am.
Thank you, sir. Good evening, everyone. On behalf of KS School of Engineering and Management, it gives me immense pleasure to welcome you all to the valedictory ceremony of the ATAL ACTE-sponsored 6-day online FTP faculty development program on nanomaterial and energy storage sustainable future, organized by the Department of Physics, KS School of Engineering and Management in association with KS Research and Innovation Foundations. I'm Pavitra J, Coordinator, Department of Physics, your host for the valedictory function. For the past 6 days, This FTP has provided a unique platform for academic professionals, researchers, and participants from across the country to engage deeply with the cutting-edge topics of nanomaterials and energy storage technologies, both of which are essential for creating a more sustainable and energy-efficient future. This program focused on understanding the innovation solutions nanotechnology offers for energy storage systems, which are crucial in ensuring that renewable energy sources like solar, wind, and hydropower can be stored and utilized efficiently. The FTP was attended by more than 100 participants from various colleges under ASCT. On behalf of KS School of Engineering and Management and Department of Physics, I extend a warm welcome to Dr. Swami Sir, Executive Director, KSRIF, as our guide and mentor in research, funding, and publications. Welcome you, sir. In his absence, I would like to take a moment to remember our Principal and Director, Dr. K. Rama Narasimha Sir, for his unwavering guidance and support, constant source of motivation in everything we do. I also extend a warm welcome to our esteemed participants all over the country, welcoming you all for this valedictory function. It is my privilege to present the summary report of the 6 days online FTP on nanomaterial and energy storage, sustainable future, organized by the Department of Physics, KS School of Engineering and Management, in association with KSRIF from 3rd February to 8th February 2025. The program was inaugurated by Dr. H. Nagana, former Board of Director, Karnataka Renewable Energy Development Limited. He gave an introductory note on importance of nanomaterials in energy sector. Following the inaugural speech, Dr. K. Rama Narasimha Sir, Principal and Director of KS School of Engineering and Management, delivered an introductory talk by welcoming the delegates and participants to the FTP. Dr. Swami Sir, Executive Director, KSRIF, gave an insight on the importance of energy storage devices and encouraged to acquire projects related to the same and the recognized bodies. Over the course of the program, a series of engaging and interactive sessions were conducted. Day 1 of FTP hosted informative session 1 from Dr. Kamal Kishore Ora, Professor of Physics at Chikara University and B.V. Raju Institute of Technology, and the co-founder of Goodleaf Mobility Provides Limited. He gave an insightful presentation on transition from CNG to hydrogen and its storage for sustainable mobility. His deep expertise has significantly enriched our understanding of sustainable mobility. The presentation also discussed hydrogen program in India and transition from CNG to hydrogen. Session 2 was hosted by Dr. M.V. Reddy, Professor and Scientist, National University, Singapore, gave a brief introduction on the present environmental progress and the need for green, renewable, clean energy technologies. He gave a clear picture of the importance of energy storage industry and the hazardous effects of CO2 in the atmosphere. The session concluded with a description of current efforts taken on the energy storage materials for vehicular technology and development of sustainable materials for the future. Day 2 of FTP, Session 3 held a talk on sustainable nanomaterials for renewable energy storage devices by Dr. Rajan Jose, Professor and Ming Chai University of Technology, New Delhi City, Taiwan. Session 4 covered a multi-phase flow by Dr. Prasanjit De, Assistant Professor, NIT Goa. His expertise has deepened our understanding of the complexities of and applications of multi-phase flow in various fields. Day 3, Session 5, consisted of very insightful talk on energy storage and smart grid by Mr. M. N. Murthy, Principal Director and National Power Institute, New Delhi. Session 6, composed of talk on modeling, simulation and energy management by Dr. Somnath Singh Gupta on Advanced Technology Development Center, IIT Kharagpur, India. Day 4, Session 7 covered a very informative presentation on biomass for sustainable development by Tilotama Srinivasa, Director, teach.emg.com. Session 8 consisted of presentation on sustainable biofuels in IC engines by Dr. R. Thirumaleshwar Nayak, Principal, Research Scientist, ILC, Bengaluru. Day 5, Session 9 held a talk on renewable energy and energy conservation by Dr. Nagana, former Board of Director, Karnataka Renewable Energy Development Provided Limited, with a keynote speaker on importance of nanomaterials in energy sector. Session 10, composed of talk on electric vehicle and smart grid technologies by Dr. C.V. Sivakrishna Rao, NIT Tiruchirappalli. Day 6, Session 11 covered an insightful talk on clean energy conservation technologies by Dr. Ishwar Murthy Muthuswamy, Professor and Srimad Vaishnav Devi University, Jammu and Kashmir. Dr. K.C. Ora delivered an informative session on electric vehicles and batteries for energy storage. The last session included a detailed talk on micro and nano heat transfer by Dr. Prasanjit De, Assistant Professor and NIT Goa. I would like to extend my heartfelt thanks to our esteemed speakers who shared their expertise and guided us through the complexities of these important topics. This development program concluded successfully, achieving its goal of equipping educators with valuable insights towards the new technologies developing in future. The FTP also fosters an environment of collaboration collaboration and growth, contributing positively to the professional development of the participants. The success of this program would not have been possible without the support of the management of KS School of Engineering and Management. Dr. K. Ramanarasimha Sir, Principal and Director of KS School of Engineering and Management. I convey my gratitude to Dr. Swami Sir, Executive Director, KSRIF, for his constant support and guidance from the start of making the proposal process to its successful execution. Thank you so much, sir, for your unwavering support and guidance from the very beginning of the proposal process to its successful execution. The constant encouragement and expertise have been invaluable and truly appreciate all the time and effort you have invested in helping our team throughout. Thank you, sir. To extend my heartfelt thanks to Mr. Kitty, sir, co-coordinator, Department of Physics, for hosting the session and ensuring the smooth conduct of the FTPs. As well, you all know that every day he was the host for the sessions, and beautifully he was hosted all the days of the sessions. So with this, again, on behalf of our organizing team of KS School of Engineering Management, we thank all the participants for their participation in these 6 days. Thank you all.
Once again, thank each and every one of them for being with us today and for all the other 5 days and gaining more knowledge in all the aspects.